So we have talked about the interactions between two planes, the parallel planes and the coincidental planes, which are overlapping planes. Now we are going to focus on the third type, where the two planes are intersecting with each other. Okay, so first of all, let's understand how two planes can intersect with each other. Okay, so if the planes are not parallel to each other, there is only one way. Okay, there is only one way the planes can interact with each other. That is, they are meeting at a line. Okay, they will meet at a line. So let me draw that perfectly. So let's say there are two planes like this. To imagine this, you can think of the book you have. Okay, so if you open the book and if you try to close the book a little bit, okay, like in an angle, well, then you can see that there are two planes, and the middle of the book will be the line in which they are intersecting. Okay, let me draw the line in which they are intersecting also. So this will be the line. So let's name the planes. Okay, let's name the planes. This is pi 1, and let's say this is pi 2, and let's say the line is L. Okay, so when you are facing questions regarding the intersecting planes, two intersecting planes, they will mainly ask you about the line at which the equation of the line which they intersect. We normally find the vector equation of the line. Okay, we know the vector equation of the line can be given as L is equals to a plus lambda b. Okay, where b is the direction vector. So let me draw that. So this is the b vector. Okay, so here what you have to keep in mind is you can do the question in two ways. First way is finding the normal vector for the two planes and using that to find the vector equation of the line. Or the second one is using the Cartesian equations directly by assuming one parametric value and moving on with that. Okay, so first of all, let's focus on the first method where we are going to use the normal vectors. Okay, so let me draw the normal vectors for your clear understanding. So this is let's say this is n1. Okay, so let's say this is n1, which is perpendicular to the given uh, mm, mm, mm. Yeah, this one is perpendicular, right? It should be a little bit this way. Let's draw it here. No worries. So yeah, this one is perpendicular. So let's say this is n1. Okay, so this is vector n1. So phi 1 is perpendicular to, okay, phi 1 is perpendicular to n1. Okay, and let's say we can find the n2 vector, which is perpendicular to the given vector. So let's say that's lies here. Okay, so no, not this one. So what about this? Yeah, this works perfectly. Okay, so here we have n2. Okay, so this is vector n2. So pi 2 is perpendicular to n2. Okay, even though we can't say about the angle between n1 and n2, okay, we can actually talk about that now because we haven't learned anything about that. But what we can really see is, okay, n1 and n2 are actually in a same plane. They are in the same plane. Okay, and that plane, okay, so we just consider this as the plane. Okay, so consider this as the plane. So if there is a plane like this, okay, some random plane, let's say that is pi x, okay, let's say this is the pi x plane, okay, so the n1 and n2 lie in the same plane. Okay, so if you consider the pi x plane, okay, if you consider the pi x plane, okay, n1 and n2 are actually parallel and lies on the same plane. Okay, so if this is n1 and this will be n2, okay, so this is what we will have. Okay, this is n1 and this is n2. Okay, the beauty of this plane and the line L is that the line L will be perpendicular to the given plane. Line L will be perpendicular to the given plane. Okay, line L will be perpendicular to the given plane, which means the direction vector of line, okay, the direction vector of line L will be perpendicular to the given plane. Okay, so if this is 90 degrees, this will also be 90 degrees. We don't know about this angle. Let's say this is theta. I mean, I will be teaching you about that in the future. But for now, let's not focus on that. If this is some random theta, we can definitely say the direction vector is perpendicular to n1 and n2. To n1 and n2. Okay, so that's the beauty of this. By using this only, okay, we are going to find the vector b. Okay, by using this only, we are going to find the vector b. Okay, so this is the first thing. Okay, this is the first thing. Okay, what about if you know the direction vector, part of the vector equation is done. Okay, but we can't find the vector a, right? We can't find the vector a. So what can we do about that? Well, they will give you, okay, they will give you a point on the line. They will give you the position vector of a point on the line. By using this data, okay, by using this data and then these two data, okay, n1, n2 are perpendicular to b, okay, we can find the vector equation of the line L. How can we find b? Well, since b is perpendicular to n1 and n2, b will be equals to the cross product of n1 and n2. B will be the cross product of n1 and n2. Okay, so this is how you have to do this question. Okay, this is how you have to do the question. Okay, so let's do a practice question to actually tackle these types of questions. So these are the two planes that they have given us, and let's say a, okay, the line, I mean the plane, they are saying the planes are intersecting. Okay, the planes are intersecting at a single line, and that line L, okay, that line L contains the point A, which is given as 3 comma 3 comma 4, 3 comma 3 comma 4. Okay, so how will you understand this is, so there is a plane like this, okay, which is pi 1, and there is another plane like this, which is pi 2. Okay, so let's say this is pi 1 and let's say this is pi 2. The intersecting line, okay, we don't know which line it is, so let's say that is L, that has the point A in it, and A is given as 3 comma 3 comma 4. Okay, so if you want to come up with the vector equation, L can be given as R equals to, okay, R equals to A plus lambda B, where B is equals to n1 into cross n2, where n1 is the perpendicular vector of pi 1. Okay, this is n1 and this is n2. That's it. So first of all, let's come up with n1. So n1 is equals to 1, 2, 3. So that is 1, 2, and 3. So n2 can be given as 4, 5, and 6. 4, 5, and 6. Since they have clearly mentioned that the planes are not parallel to each other, they are saying it is intersecting. Those two planes are intersecting. So you don't have to prove that here. But if you had to prove that, you know how to do this. Okay, just find the ratio between the coordinates. If the ratio is equal, we can definitely say n1 is parallel to n2. Therefore, n1 is parallel to the n2. Therefore, the planes are parallel. Since they are not parallel, we can say they are intersecting. Okay, now how are we going to find b? Well, by using the vector product. So I, j, and we have k. First of all, let's write down 1, 2, 3, and let's write down 4, 5, 6. Okay, so that will be equals to I into 12 minus 15, okay, minus j into 6 minus 12 plus k into 5 minus 8. So what's the value? Well, that is equals to minus 3i plus 6j minus 3k. So the direction vector b, okay, the direction vector b can be given as minus 3, 6, minus 3. Okay, but we know in direction vectors, we only care about the direction, not about the magnitude. So you can actually take minus 3 as a common factor. So it will be equals to I minus 2j and plus k. Okay, so you can use this as the direction vector. Why? When you are finding the vector equation, this minus 3 will go into lambda. Okay, so the minus 3 will be contributing to the parametric value of lambda. Okay, so you don't have to write down the minus 3 here. So you can give the vector equation of L as L is equals to R equals to, since we know A, which is given as 334, I'll write that down, 334 plus lambda into 1 minus 2, 1. 1 minus 2, 1. You can write 3 minus 3, 6, and minus 3, but it doesn't make a difference because they are parallel vectors. Okay, so if the direction vectors are parallel, they just represent the same line. Okay, so keep that in mind. This is how you have to do these types of questions. Okay, so this is the first method. In the next video, we will be focusing on the second method, where you will be uh, using the parametric method to find the equation of the line. In that question, you won't need the point on a line. You won't need the point on the line. Okay, so you have to be clear to which question you are applying the method. Okay, so method 1 can be applied if a point on the line is given. Okay, they may say it's a point on the line, or they may say a is a point on both planes. A is a point on both planes. They may even say that. Okay, they may even say that. Okay, so that's how it works. They may even say that point A lies on both planes, which means the point lies on the given line. Okay, well, that one.
Thanks for watching the 36th video in our vector series. If you found this explanation of finding the line of intersection between two planes helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.